Hello and welcome to the session. In today's session, we will be discussing about the fractional knapsack problem and we'll try to find a solution to this particular problem using greedy approach. But let us first define the fractional knapsack problem, the knapsack problem itself. And first we will define the knapsack problem with the help of words, and then we will define this particular problem with the help of some mathematical notation. So what is the knapsack problem? Well, for the knapsack problem, there are the things which are given are a knapsack or a bag. Knapsack is just a bag of some capacity, okay, and the capacity can be defined. One of the ways of defining the capacity is a weight limit of the bag. So suppose the bag can carry 10 kgs, 15 kgs, whatever. So that is the weight limit of that particular bag. And in addition to that, so we have a bag and our objective is to pack in that particular bag a set of objects such that objects has we maximize the profit. That is our objective is. So we are given a set of objects and each object will have a weight and that object will have associated profit, right? So what is exactly the problem or its objective? Fill the given knapsack, fill the bag with the object such that the sum of profit associated with the objects that are filled in the knapsack is maximum. So we are trying to maximize our profit and we are filling only those objects which are maximizing our profit. But the constraint in that particular case happens to be the knapsack has a weight limit. So definitely this problem will be, the problem will be real problem when the total weight of the objects put together is more than the capacity of the bag, and that is where we need to make a decision, right? Now you can fill the objects fraction to knapsack, therefore the name fractional knapsack. So the problem which we will be discussing today, where we are allowing you to fill the bag with just fraction, like half of the weight has been filled up, half of an object has been filled up. So if object was of 10 kg, then only 5 kg has been put. So that is allowed in this particular case. And there is another knapsack problem which is called 0-1 knapsack problem, where either you fill the whole object or nothing at all. But in both the cases, the objective of us is that we should be able to maximize the profit. And what we will be discussing today, we will be discussing the fractional knapsack problem. Now, if we look at this fractional knapsack problem, what kind of problem is, what exactly we are trying to do? Obviously, we are trying to do optimization. Why? Because we are finding the best optimal solution from the possible solution. So we are optimizing, like one of the solution which gives us the maximum profit, right? That is the real the solution to this particular problem. And the technique we would be following to solve this particular problem is greedy technique. Okay, so what greedy technique will do? What we will do, we'll try to select the best available option from the current problem. So once we have selected the best option, then we will move on to the next. Okay, so the best option has been selected. From the remaining, then we will be selecting the whatever is the best option, like that. So greedy approach, this is what is the greedy approach. And in greedy approach, once you have selected a particular option, you cannot return it. So you can go on to do next greedy step only. You cannot just return back to the original state, okay, then and you find that the putting things together, if two things are put together, then that is turning out to be a better solution. That is not allowed. You pick up solutions one by one, right? And here also we will be picking up objects one by one. So that is the essence of greedy approach. So how we are going to solve the fractional knapsack problem with the help of greedy approach? But let us define the problem in a slightly mathematical terms. So given, what is given? A knapsack of capacity W. So W is defined. It can be kgs, grams, it does not matter, or it can be a quantity. But for the present time, let's keep or let's assume that this we are talking about the weight of the object. Then a list of n objects, say O1 to On. So these are n objects. Their numbering or their naming is not that important, but each object has a weight, small w, okay, Wi. So ith object has a weight Wi, and a profit associated with that object is Pi. So if I pack a particular this particular Wi weight I into the knapsack, I'll be gaining Pi profit because of that. And finally, since it's a fractional knapsack problem, so we are saying a fraction where xi is a member of set from 0 to 1, right? And in between, we can say that there are many real numbers. It can be 0.1, 0.2, and so on till 1. So we can pack a fraction of object OI, right, in the knapsack. We can pack 0 also, or we can pack 1 also, but we can also pack the fraction. So that is why xi is a fraction. So we can place any object in fraction into the bag. And then profit of functional object. So if fractional objects happens to be Pi and Xi. So if I have packed, let's say, half of a particular object, then its profit will also become half, Pi into Xi. So that way, this is what it is. So profit of fractional object becomes Pi into Xi. And the problem objective is fill the knapsack up to its maximum capacity W such that the total profit earned is maximized. Now further, we can represent it as I said, an optimization problem, and the optimization problem in this particular case becomes that maximize, what we are maximizing? The profit, and the profit was Pi into Xi, the fractional profit of all the objects which we have filled up, summing it up from I is equal to 1 to n. Remember that some of the objects, the quantity will be 0, the fraction which we are packing may be 0, some of the object, the fraction we are packing may be 1, some of the object may have quantity or the fraction which we have packed is 0.1 or 0.2 or half, whatever it may be. However, this particular maximization problem, right, the optimization problem, is subject to a typical constraint. And the constraint is that the sum of all the fractional objects, right, sum of all the fractional objects should be less than or equals to W. Ideally, it should be equal to W. That's why we are allowed to have fractional object in this particular case. And as earlier, the value of the fraction xi, which happens to be fraction, can be 0 till 1. So any value between 0 to 1, where the value of, that is the for all the objects. So this is representing from first object till nth object. So for any amount we can pack within the knapsack. So now the problem is very much there. Okay, now how to solve it with the help of greedy approach? Let's try to understand this with the help of an example. An example gives a lot of insights into it. Then we will follow it up with the algorithm, and finally we will try to find out what is the complexity of that particular algorithm. Well, the example of knapsack, we are just taking n equals to 3. So there are 3 objects, let's say, and capacity of the knapsack, let's assume, is 20, right? And the profit associated with these 3 objects, n equals to 3, profit of first object is 25, second object is 24, and profit of third object is 15. And the weights associated with the object are that first object is of the weight 18, second object is of weight 15, and the third object is of weight 10. Now the knapsack or the fractional knapsack problem is asking us, what should we put in the bag, right, so that our profit is maximized. Now what can be the approaches for that? Right, so we would be using greedy approach, but even in greedy approach there can be 3 greedy approaches in this particular case. First, let's start with the maximum profit, right? Then the second approach, we start with the maximum weight. And the third approach, we will do something, some mathematical operation and try to find out. So the possible greedy strategies from the remaining. Now what we are going to do? We are going to do this particular thing from the remaining objects only, right? So from the remaining objects, what we are going to select? The object that has the maximum profit that fits into the knapsack. So this is the first approach. So let's look into this approach. That's okay. So what we have the so we are selecting that object. We are filling the knapsack with that particular object which has the maximum profit. Maximum profit, if we see the slide, right, is written over here, 25. So P1 is 25. That happens to be the highest profit, right? So the first object, okay, first object in this particular approach, let's select the entire object, okay, the entire first object. Now the first object's weight is 18. Why? Why we are selecting what? This is the approach we are following. So we are taking the maximum profit 1, right? And maximum profit belongs to P1 or object 1. Okay. And what is the weight of that particular object 1? It is 18 kg. So what we are left with? Only 2 kgs, right? So we are left with 2 kgs. Then the next best profit belongs to object 2. Right? And object 2 has a weight of 15. So we will be selecting only 2 kgs out of the 15, and third one will be nothing, right? Because that is how the problem solution is. We picked up 1, 2 by 15 for the second, and nothing for the third. So we have satisfied the constraint. The value of xi is between 0 and 1, all the cases. So this is the weight you can figure out. The weight is 18 plus 2 kg equals to 20. And what is the total profit in this particular case? The total profit is Pi into Xi. So Pi is 25 into 1, right? Because we have filled up the entire object. So 25 plus 2 by 15 into the profit is 24, because that is what we have filled up of the second object. So when we compute this particular thing, it turns out to be roughly 3.2, and what we get is a total profit of 28.2. What happens if we follow the second strategy? Now, second strategy is select the object that has the maximum weight that fits into the knapsack. So okay, that has the minimum weight, not maximum, I'm sorry, weight that fits into the knapsack. Now if we look into the weight, so we are starting with 10, 15 and 18. So it is other way around. So the third object, object 3, has the least weight. So we pick up that particular object, okay. So we have filled up 10 from x3 object. So weight 10 has been filled up. So what is the remaining weight? Is the 10 kg left, because we have filled up 10. The capacity was 20 kg. So only 10 kg is left. So 10 kg. Now the next lowest weight is 15. So 2/3 of 15 is 10. So we fill up the 2/3 of that particular object into the knapsack or the bag. And once we have filled these two up, then there is 0 capacity left for the third object. So once again, we compute the profit of the total weight for this. Obviously, it is going to be 20. That's how we have computed. What about the profit? We have not filled up anything of object which has a profit of 25. So that becomes 0. The 24 object we have taken 2 by 3rd of that object only. So it will be 2 by 3 plus 15 is the weight of, that is, we have completely taken this particular object, we have taken it as 1, so 15 into 1, so total weight becomes 31. So we can see the strategy 1 has not yielded or not got us the best results. So the greedy approach, if I'm selecting just that picking up just the profit, right? Just the profit and then selecting greedily the profit, it's not working. Though weight in this particular case is turning out to be better, but probably they may be, both of them may not be the right kind of strategies to solve the knapsack problem. In fact, the third strategy, select the object with maximum PI upon WI, which is basically the profit per unit weight. Now, this seems to be, or this strategy seems to be most logical greedy strategy, okay, that fits into the knapsack. So this is the strategy which we are going to utilize, and probably this is what this strategy should give us the best result and solve the knapsack problem in that particular sense. So let's try to divide 25 and divide its related weight. So 25 by 18. Now you can see per kg it is giving just 1.39. Okay. Whereas 24 by 15 is giving us 1.6. And 15 by 10 is giving us 1.5. So which is the best one in this particular case? Obviously is object 2. Right. So as per this particular approach, which happens to be the best approach, let's pick up object 2, complete of that particular object 2. Once you pick up that complete object 2 is of 15 kg. So knapsack now is only left with, the knapsack has only 5 kg. And that 5 kg we pick up from the first object. Oh, sorry, third object. So that is 1 by 2 of 10. Which becomes 5. So this is the total weight, and what you get in this particular case, the profit, okay, once again the first object has not been filled up at all, but the second object has been taken up completely, so it is 24 into 1, okay, plus 1 by 2, half, because we have taken only the half of the third object, and the profit of third object is 15. So it turns out to be, we get 7.5 here, and we get the best figure over here, 31.5 out of these three approaches. So the approach where we are dividing the per unit, right, we are taking profit per unit weight. That is the approach which is working as far as knapsack problem or solution to the knapsack problem is concerned. So once we understand this particular logic, the next thing which we need to know is how to solve this particular problem, how to write algorithm to this particular problem. Because whenever you, first of all, whenever you get a problem, first try to identify how you are going to address it just on piece of paper. Once you are able to do that, the next best thing to do is to find the good algorithm to solve this particular algorithm. And we have selected the greedy approach. So there has to be this greedy approach. We have found out that PI divided by WI, right, taking the per unit, a profit per unit weight may be a good approach to take a good approach as far as greediness is concerned, greedy approach, which is going to solve this particular problem. So let's write algorithm in that particular context. So how or what kind of algorithms which we will have for fractional knapsack greedy algorithm? So input, now when we are talking about input, we are talking about the weights. So weights we are taking W, and 1 to n, basically it's an array. So weight is an array of n integers representing object 1 to object n. Okay. Profits are also an array of n integers representing profit of first object number 1 to object number n, and assume profit and weights are sorted by PI divided by WI. So what we are assuming that our sequence is already a sorted sequence, but that sorted sequence actually takes maximum amount of time in knapsack when we try to find out the complexity of this particular algorithm. The next thing we know is capacity of the knapsack, which happens to be W. So these two are the input. Okay, and what output we are expecting? We are expecting an optimal solution which is giving us fractions in terms of x, right? x1 to n. So these basically are representing the fractions of different objects which are to be packed in the bag. Okay, now we have four steps which are written in just one line because they are initializations. And in the initialization process, what we are basically doing, we are running a for loop, okay, initializing all fractions, right, to zeros, the overall profit as 0, and which basically represents the total or overall profit, and overall weight which has been packed so far into the knapsack is also 0, because initially total profit is 0, weight are 0, and then greedily we will pack one object after another. Now next is we take the value of I as 1. Now what is our assumption over here? Profits and weights are sorted by PI divided by WI, which is profit per unit weight. That means the best profit per unit weight, that particular object is object 1. Right. So if that is object 1, that is the value of I, while weight is less than W, we have not packed anything. Then the next line is if weight plus WI is less than W. So if that happens to be true, okay, weight plus weight I, that means we have added the weight of the object to initial weight. Initial weight is 0, right? So if it is less than W, well, that means the object can be packed, right? So you completely pack that particular object, you assign Xi as 1. So x1 will become 1, and the weight now will become the weight, the initial weight is 0 plus the weight of the ith object, which is first object. So that will added over here. Else you will find out, obviously this is less than W, so you will be, that means the overall weight of the object is more than the size or the size of the knapsack or the weight which is allowed in the knapsack. If that happens, then this particular lines allows you to pack only fractionally, as far as object fractionally into the knapsack. So over here the fraction would be computed where W minus the weight, whatever is the weight of this particular weight Xi, is this particular thing will be subtracted and divided by total weight, giving us how much fraction can be packed into that particular object. And then finally you compute the profit using the PI into Xi formula, and that is how you complete your algorithm, and this is how the fractional knapsack algorithm runs. Well, if we try to look at one of the example how this particular algorithm is running. So in this particular case, we are taking an example where objects numbering is, we are not using PI divided by WI in a sorted order, but just to demonstrate. So suppose this is the problem where weight is 2, 3, 5 like that, and profits are associated profit, then we will compute PI by WI, and this is what is going to be computed first. Once this is computed, actually this particular data should be sorted, but we have not done it. Right, we have not done the sorting, otherwise you can do that particular sorting. So we start with first object. This is the maximum, right? The PI by WI is highest here. So this particular object will be packed completely. Why? Because the weight is only 1 and total weight which we can pack is 5. So now how much is to be packed? 4. Now for 4, what we find out, the next best is 5. What is the weight? 2. So we pack that, 4 minus 2, 2. So once again, the fraction which is to be packed is 1. That means the whole object, that is object 1, is to be packed. And the remaining now capacity, the third is in this particular list is 4.5. So here we have 4. Obviously we will be packing the fraction because only 2 objects are left. So we will be packing 2 by 4, which happens to be just 2 of the object. So that's how the overall capacity will become 0, and total profit will be PI into Xi. It is 10 because it is 1 into 10, 6 into 1, and because this is 18 and we have packed 2 by 4, so we get 9, and total profit we get is 25. So that is the way the algorithm will work out the solution, right? So with this, I come to almost the concluding part. But what we have discussed in this particular session, we have talked about the fractional knapsack problem. The greedy algorithm is used to solve the fractional knapsack problem, where we have used the PI divided by XI, that is profit per unit weight, as our basic defining criteria. The maximum value of that is, the object with maximum PI by XI is selected to be picked up, and a fraction in the last. And the complexity of this algorithm technically is order n log n, which actually belongs to the sorting of the values of this, whatever is needed as far as this algorithm is concerned. So with this, I end this particular session. Thank you for being with me.